For everybody who was lucky enough not to see this presentation already, I wanted to spend a few minutes and talk about SCI's experience running on x86 VMS. A little bit of my background, I'm sure you read this already. So we'll talk a little bit about some history, a little bit about our involvement, some of our experiences porting our applications, and some of the areas where I expect that you will have some challenges or opportunities depending on your point of view, depending on your application. So VMS has been running on x86 for a very long time. We had VAX emulators from several different sources. We've had alpha emulators from several different sources. So running on x86 and disconnecting yourself from the hardware is not novel. But somewhere along the way, there was discussions you would hear over here in the bar of people talking about running VMS on x86 natively on hardware. And then those rumors got a little stronger, but no details. VSI shows up and saves the world of VMS. And then there was public discussion of, we're going to port. Nobody really at the beginning knew exactly what that meant, but we had some evidence because we've seen VMS being ported from VAX to alpha and then from alpha to x86. So the idea was it would be similar. And then we started getting tools from VSI to be able to cross build. So I could, on my Itanium system, I could compile my C program and it would produce code that would run on an x86 computer long before we ever had any ability to run it on an x86 computer. And then finally things dribbled out and eventually versions get released with V's instead of X's, and then we can start running. So along the way during this presentation or any of my presentation, please feel free to speak up if you have a question, or if I say something offensive, point it out for the rest of the audience. So Brad mentioned that I think early in 2020, Claire Grant sent me a note very nicely and said, are you ready to help us out with an experiment? And he said, you're going to run x86 on VMS. Of course, I said yes. And then I asked Brad if it was okay. And he said, fine. And we were pretty excited because this was a great opportunity to help out VSI, who we cooperate with, as well as run some new technology. So a couple days later, I got a zip file of a bunch of machinery and a whole bunch of instructions written by technical people who didn't understand the English language very well, but interpreted all of this. And well, you know, he tried. I mean, I give you credit. But and it worked. And it was a little bit kind of anticlimactic because I type show system and it just does what show system does. I mean, there was no exciting new thing here, except that I'm now running on x86 natively. So anyways, that was within hours of receiving the software. So great, we have VMS running on x86. In my experience, nobody runs VMS just because. Nobody runs VMS to run VMS. They run VMS to run an application. They run their factory or calculate weather forecasts or do stock markets or whatever it is that you do. That's why you're running VMS. And most of the time, you have computer programs that run on VMS, and that's what you're hoping to do. So over the years, I've been fortunate enough in my career to be involved in multiple ports from one architecture and in some cases one operating system to another. So I was involved at Digital with porting applications from VAX to Alpha. And then I was involved at Oracle porting an application from Alpha to Integrity. And so we've got everybody in the company has worked for at least one company that has migrated one little piece or many big pieces from one architecture to another. So we have a lot of experience. We know what to do. We know how it's going to occur. And some of this stuff is my own app, my own code that I've written that I need to port. Some of it's freeware that I got off the internet, where I spend almost all the time fixing the command procedure that builds the application in order to compile it. And then some of it's big things like RDB, where there's thousands of modules written in different languages that do different things. So the complexity is varied from simple to huge. I said this a lot during the x86 port in different ways. What you should expect is I compile my program, I link my program, and I run my program. And it just works. Maybe some people will even test their program, but that's what you should expect. That's the behavior that will become typical for you. If you can compile it on Integrity today, if you can compile it on Alpha today, you can compile it on x86. I'm lying to you a little bit in some cases, but that's your expectation. Anything else is a compiler bug, and you should focus on that. If you see a problem, it's not your fault. So what do you get when you boot VMS on x86? Basically, everything is there. The clustering and MSCP disk serving and the directory command and the RTL calls and systems. Everything is the same, except where it's not. But TPU's there, the sysgen command's the same. It just works. Again, kind of anticlimactic. If you're looking for something new and exciting, you wouldn't even know that you're logged into an x86 machine in most cases. The language compilers, for the most part, act the same. The kind of the COBOL compilers front end takes the same language, does the same things. The back end of the compiler might produce different code. This is true mostly. There are some exceptions to what I'm saying, but for the most part, if you've got Fortran, COBOL, BASIC, C, it's going to work. Don't worry about that. And when it doesn't, again, it's a bug. During the Alpha port, but much more during the Itanium port, we spent way too much time talking about floating point. Oh, we're going to IEEE native, and there might be some rounding error differences, and da-da-da-da-da. All of those things are still true, and they still, as it turns out, really don't matter. The world that I work in is mostly commercial applications. Your banking system, hopefully, doesn't do a lot of floating point arithmetic with your bank balance, so it doesn't matter, mostly. There are going to be differences. They tend to be very small, but not always. The rounding behavior between VAX floating point and IEEE floating point, the rules are different, but again, it doesn't matter. There is some inability to store the same magnitude and precision. Mostly it doesn't. Is anybody doing weather forecasting on VMS or seismic geological number? Yeah. You don't have these problems mostly. Okay, it's no longer 1986, despite some of my customers' belief otherwise. If you have not already rebuilt your application using IEEE floating point format, try it. You probably don't do a lot of floating point anyhow, but where you're going to run into trouble is where it's stored on disk. So if you're storing floating point numbers in your RDB database, if you're storing floating point numbers in your RMS files on disk as binary, not strings, you may have some challenges, but they're the exact same challenges you have right now in Integrity. So again, like I said, we worried about it a lot. We talked about it a lot. Didn't turn out to be that big of a deal. If you're migrating directly from alpha to x86, and you use my favorite RTL routine lib$wait, chances are you're going to be sad, and you'll need to add a parameter. Sorry. So here's a quick little demonstration that I ripped off from a presentation I did a long time ago. And I've got a simple 5-line basic program that, depending on how I compile and where I compile, I get different answers. Again, it's something that I created just for this example, but nonetheless, a floating point number is always an approximation. That's all you need to remember. And if it's slightly more or less approximate than than some other floating point value, I'm sorry. Any questions about floating point? Does anybody use floating point in real life? Okay, good. All right, data alignment. Something else we've spent gallons of ink writing about over the years. On VAX, it didn't matter because we weren't very smart and we didn't understand what was going on in the hardware anyhow. On Alpha, it mattered because the Alpha computer didn't know how to read and write bytes at the beginning. On integrity, it turns out it mattered a lot. And punishment of data alignment mistakes was severe at the beginning, and then got less painful over time. On x86, we're back to the VAX days. It really doesn't matter anymore. So yeah, there should be no functional impact. Your program will work the same. Different performance arguably may or may not occur. What I will share with you is, yeah, natural alignment is better. The computing world is safer and more comfortable. If your program works, don't fix it. Don't try to align data to look good. Align it because you're solving a real problem. And I'll also tell you, if you're using RDB and you try to align your record layouts till they make sense, RDB does terrible things with your data once you give it to RDB. So anything that you've tried to do is destroyed. Does that make sense? Okay, good. The other thing we've discovered about x86 over time is that it's not bug for bug compatible. If your program is illegal or non-compliant and it happens to work today, good for you. There's no guarantee that your illegal or non-compliant program is going to work or work the same on x86. So just because you get an access violation doesn't imply that there's anything wrong with VMS. In most cases, it's still your fault, whether it's an uninitialized variable or some assumptions made about how memory is laid out on the stack and stuff. Timing and how things occur and when they occur is guaranteed to be different on x86. But again, most programs, most of the time, not a problem. The stuff that ends up on disk, we went to our Heinz presentation talking about index files, the same. Everything on disk is the same. How do I know this? Because my cluster has x86 systems and alphas and integrities all accessing the same data at the same time in the same files. So if there was any incompatibility, those programs would no longer work. It's the same. TCP/IP version 6. I love it. It is the best software ever that I've ever used. It acts pretty much like it did before. There are some differences. NTP, for example, is a brand new NTP. SSH, for years, your security team has complained about VMS SSH because it doesn't do the latest MAC algorithm, key exchange, yada, 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 whatever, DSS, I don't know. It now supports all of those things, OpenSSH, but it doesn't do it exactly the same as the old SSH from HP or Compaq. So be aware that you might have to change things slightly, like if you and I'll make something up. If you have SCP commands embedded in your command procedure to copy files here and there, you might have to add some double quotes. I'm not promising, I'm saying it's close, it can be made to work without any effort, but it's going to require a change. All right, the CPU, the processor, the x86 is the most disgusting piece of silicon ever produced by humankind. Don't worry about it. The last thing you want to know is what it looks like under the covers. Just compile your COBOL program and run it and be happy. It's different. It's more similar to architectures of the 1970s than it is of the 1990s. Don't worry about it. Works fine, lasts a long time. The VMS calling standard, and I probably say this too often to too many people, but read the book. If you're writing programs on VMS, read this book. It makes everything else perfectly approachable. It's 1,000 pages of incredibly boring detail and exceptions and pictures and all these things, but it's how VMS works. And the calling standard between the 4 architectures is family familiar. You kind of get the job done. The implementation of how registers are saved and restored and following the stack backwards and forwards to do exception handling is much different. And if your application is traversing the stack, trying to find things, you're probably doing something wrong already. So stop and come talk to me before you continue down that path. All right, let's talk a little bit about what we've done. Initially, well, kind of not initially, but once we started to get systems up and running, due to some hardware constraints that we had, as well as some other decisions, I was running VMS on top of Oracle VirtualBox, running on Linux, on top of VMware, on top of my hardware. Completely functional, a little clumsy, took some extra hand-holding. Numerous times I would report a VMS bug. System crashed for whatever. And the word would come back from the highest levels of, we're not going to support you because you're doing really dumb stuff. And it was a VMS bug anyhow. So even though they got to chastise me, it was still broken software. Since then, I've scrapped all that, just run VMware natively, simpler, faster, easier. So my main development cluster runs x86 and Alpha and Titanium. There used to be a VAX in this cluster. However, VMS version 6.3, I think we were running, won't participate in a cluster with 9.2. And I've been too lazy to upgrade my VAX system. So otherwise, we'd have all 4 architectures. So our SCI's code that make up sort of what we are responsible for is a couple thousand modules, multiple languages. We've got Fortran and COBOL and Bliss and C and some TPU programs, awk, I don't know, other things. I have to produce kits of our software for distribution that we distribute to run on our customer systems for VAX Alpha, x86, and Integrity, VMS 6.2 all the way to 9.2. So it's kind of an ugly, complicated build environment because some programs I can build for 7.3 and they'll work all the way up to 8.4. Some can't because they're linked against the exec, and it's just kind of ugly. And to simplify things, I have build queues for each different style of thing. So there's a queue that I submit VAX builds. There's a queue that I submit x86 builds that are native versus x86 builds that are cross. And I've managed to make it complicated enough that I'm now indispensable to the company because nobody else could figure it out. So initially, just about everything was built in the cross environment that I talked about. So I did my builds on integrity servers that produced executable images that would run on x86. And then over time, I started migrating them as compilers became available, as different tools became available, started migrating those to native one at a time. There's a couple of things that don't work yet for a couple of different reasons. The easy example is I have a bunch of code which uses RDB. I don't have RDB, so I can't even build it at all. There's some missing pieces, just very small things. And then, of course, like I mentioned, the open source build command procedure where I got 6 modules and an 8,000 line DCL command procedure that attempts to figure out everything in the world just to be able to compile these 6 modules. And I've just given up. Some of them I fixed, some of them I scrapped, and some of them I keep avoiding. Where you're going to have to make code changes, you've heard this before. Any place where your program thinks that it needs to know about alpha or i64 or VAX probably is going to have to be changed. If the developer who preceded you was smart enough and said, if not VAX, you're probably going to get the right result. If the developer before you said, if alpha, then do this, else do it the old VAX way, you're going to have to do work because you need to do it the alpha or the integrity way. DCL has the exact same problem in a couple of cases. There's a few boundary cases. There's built-ins that probably nobody in real life uses that are going to require some little bit of massaging. If you've written code in integrity assembler, you have other problems in your life that I can't help with. So where did I find problems along the way? Almost always, if there are bugs in the code, it's because there was a bug in the code before. Uninitialized variables, there's some long latent assumptions made by the program. It just happened to work forever. There were some stack accesses out of scope that didn't cause any harm before, but now make the program stop. There's a couple of places where somebody believed that they understood how the language was going to align data elements in memory. That is no longer true. Stuff like that. I was involved with multiple iterations of field test compilers and field test linkers and field test debuggers along the way, with generally good forward progress. Occasionally we miscommunicated. Increase your quotas. For goodness sakes, don't be afraid of memory. Working sets, grow them. Page file quota, grow it. Byte lim, grow it. Somebody on one of the boards, the VSI board, had some problem with the linker or the compiler, and it was just byte lim. You know, make it 100 times bigger and keep going. All right, less usual cases. I've seen some of these in real life. I know about some of them. If your code knows about any of those 3 statuses, again, you've probably made some poor life decisions to get you here. Come talk to me. If you're writing in iMacro, the on integrity, again, we talked about that. Macro 32, probably you're going to be in pretty good shape if it runs today on integrity. Alpha macro, probably you're going to be okay if it runs on integrity. Both of those will have some very small boundary conditions, but you're probably in good shape. If your program knows nasty details about the calling standard and stack traversal and exception handling and stuff, you're going to have to do some work. That might be a little bit of work, might be a lot of work, but that's the way it are. And if you are one of these people that I'm talking to, just come visit me afterwards. We'll keep it confidential. You don't need to embarrass yourself. One of the first things that I did when I got this brand new VMS system and the cross tools and stuff was So I've been developing on VMS and PDP and PDPH since a long time. And Tico was one of the first editors that I have a lot of affinity for Tico. So I went online, I found Tico C on the internet and downloaded it and changed the command procedure, compiled it and linked it, and it ran. So this was like within 2 months of getting x86 VMS, I had Tico running. It is easily the least portable computer program developed ever. So anyways, that's, if you're a Tico person, there's hope. I sent this basically this output to Andy Goldstein, and he was so excited. So over time, we started getting things working, and I could do builds, and I could do more native builds and more native builds, and things were looking good. I felt very confident until 1 out of 10 times, one of my command procedures that builds, I'll have to think about what one it was. Anyways, the runoff command would get this terrible error message, and it would break. Only on x86 and 1 out of 50 times. So I diligently reported this to VSI. Hey, something's not working right. And gosh, within, I don't know, 9 months. Anyhow, so this is an example of a latent bug that's been in runoff probably for 40 years. Oh. Since forever. Yeah, so just a quick little slide. Runoff is written in Bliss. From decades and decades and decades ago, there was a library called Export that had a bunch of Bliss macros. And there's not one export library. There's about 10 of them which call themselves Export. So even figure out what one you're using is tough. But there was some code in there which made some poor decisions. And so it was accessing outside, at the end, it was accessing outside of the stack frame, and once in a while, it would fail like this. And the finest engineers in all...
That was so big.
Well, you found it. He fixed it. Between the 2 finest engineers in all of VSI were able to conspire.
Yeah, you can maybe be as lazy.
It was a good exercise. That's the first thing I used to block the bugger on. It was barely functional, and I would step my way through it because I want to verify the bug. And half the time I would get far enough into the bug would crash, and I would use some expletives and start over and work the way around. So the exercise to fix the bug and to make my bug list.
But that's the kind of collaboration we had historically, as things are coming online and more things are starting to work, you find more and more things that don't work. This is sort of a gimme fun slide. So completely innocently, I managed to type the DCL command job by mistake. It's probably trying to write something else, which got me to help job, which talks about submitting batch procedures that read their input from punch cards. This output right here came from an x86 brand new system. So I started researching on USB to punch card readers so that I would be able to test this as part of my responsibility to VSI. But even more, so we all know about Hollerith, right? These are called Hollerith cards after Robert Hollerith. Anyways, some guy who used to work at IBM a long time ago. He gets all the credit. However, Charles Babbage was the guy that described with this sentence punch cards. 1830s. He figured all this stuff out. He never built one, but nonetheless, I enjoy the fact that we have 200 years of history in the help job command. But back to reality. done a couple of customer applications. And again, this is sort of anticlimactic because you compile it, link it, and then it runs. One customer doesn't actually need to go to x86. They're fine where they are, but they need to be able to demonstrate that they could move to x86. So I took their application and a couple thousand modules of, or a couple hundred modules of Pascal, fixed their command procedures. They had a couple inherit files that made some poor decisions. That was easy. And I compiled it and linked it and I ran it and it just worked. Again, it's a sad story because there's no heroic behavior in getting your application ported. It just goes. They did have one fun part. They interfaced with the CA, which is the Poly Center, which is the VSI watchdog, includes a library that you can call and like send messages to say, I'm alive or whatever. This code doesn't exist. So I wrote a tiny little routine, which returns success, put it into a shareable image that I could link against, and then it ran. So if they finally decide to go into production, I'll have to fix that code to do something real. Another customer application is involved in international monetary finance, banking, whatever banks do. And we had developed for them an application to prove to their auditors that nobody changed their executable code. There's probably a real official IT term for this, but anyway. So I wrote this package for them, and then now we're looking moving to x86, and so I rebuilt the package. And unfortunately, it didn't work because I decided to move to SSL3. And if you don't know the story of SSL, why we have SSL1, SSL111, SSL112, and SSL3, and it's because the SSL people keep changing the calling interfaces. Of perfectly good working routines, you cannot call the same way any longer. So anyhow, once I figured all that out, I fixed it, it built, and then I ran it and it failed. And turns out it was a flaw in the basic field test compiler that I think turned out to be because of a flaw in the Bliss compiler, that the basic compiler wasn't right. Is that still an accurate statement? You probably don't even remember. Not important.
They do, like, it's close.
Yeah.
Let's go with yes.
That's what you told me at the time. All right, so where are we today? We're running 9.2-3, all on VMware. We still have a few things that I can't build natively, mostly because I'm lazy, not because of any technical impediment. There's still the big question mark about databases, and really the first customer that comes to me and says they need to migrate will be when we have the real discussion of what do we do. Got ideas today, but I don't know. Other third-party products, I've got somebody who has a PDF converter or something, I don't know, whatever it is, it runs on VMS, they bought from somebody else. We'll have to address those problems when we get there.
When do you think, if you're best guess, when do you think RDB will be here?
So the question is, when do I think RDB is going to arrive? Remembering that I used to work there.
Yes.
And I ported from one architecture to another.
They first have to fix these bugs.
That's a disclaimer.
Yeah, I don't know. I would do the same thing that you would do, and I would ask Oracle directly to get on paper what they're going to do. I was here in Boston last November when the head of the RDB engineering group told us that it would be out in Q1 of this year. I don't know. I know that internally to Oracle, RDB, parts of RDB work. Is it perfect and flawless yet? Obviously not. So I don't know. I wouldn't buy a lottery ticket based on my prediction. Okay, performance. I can't tell you, okay? I don't have the best hardware to play with. I don't have any really great workloads. I can tell you that as CPUs get faster, as storage gets faster, as VMS gets better and faster, performance will improve. What I want to do is get a great, robust, very expensive, powerful system with some modern state-of-the-art NVMe disks and stuff and do some IO testing. That said, I'm going to share with you some information. I don't promise that anything I'm going to show you is repeatable. I was doing this all without adult supervision. I don't really know a lot about performance modeling and tuning and characteristics and graphs and stuff. So don't make any decisions, especially about budget, based on what I'm going to tell you. Everybody good with that? It's not my fault. So I started out, I've got a handful of performance tests that I run on all different kinds of computers at different times. And I started out with this prime number generator. And so this left-hand graph, the performance is basically too fast. Okay, I've got my alpha and I've got my emulated ES80 and this and that and the other thing. It's almost instant on x86. My guess is the compiler figured out the answer. It was a better enough compiler. I don't know this for a fact. But my CPU mem performance test is, like 3 times faster than the best of any of the computers that I had available to me. So faster is better. Again, I'm not promising you're going to achieve this in real life.
CPU numbering, is that to say, what have you allocated for these?
Say it again.
How many cores have you allocated? The same number?
So both of these tests are pretty much single process, non-threaded application. Most of my x86 machines are 4-core. Yeah, 4-core.
Okay, so this is not a multi-threaded application.
No, this is simple.
Okay.
Commercial workload.
Then,
Done. We'll get
I
there.
understand your.
Yes. So you're familiar with the ancient DCL command sheet or VUX.com, which was a terrible thing back in the 1980s. It's just as terrible today. So the higher number is the better number. The fact that we are faster right now than my emulated ES40 on some pretty robust hardware, and getting pretty close to my i6 integrity server. We're getting there. Okay, this is really, really good news, especially because DCL is an awful language from a performance standpoint. It's interpreted, it spends all of its life calling RMS to read the next line of the command procedure. It's bad. Okay, here's another test. I got this off the internet, stream.c. It does whatever stream does. Better, almost as good, whatever. So does anybody here sort data occasionally? Use the sort command or use an order by qualifier in their database query or use convert, which implies a sort. So here, very, very naive test, but I'm comparing on the left my CPU and elapsed time, and then on the right is hypersort. So change one logical name, and it's whatever that is, 5 times faster. So if you haven't done hypersort, and also you need to sort data, and your boss would be impressed if things went faster, this is worth looking into.
So Norm, how is the CPU time more than the elapsed time?
Yeah, so hypersort, from the naive use of hypersort from the DCL command prompt, is multi-threaded. And this actually is not the finest example of where it gets better, but that's why it uses more CPU than elapsed time. Usually it's the other way around. And also, in this particular test, the results are the same as traditional sort. All right, so so the landscape is constantly changing. What I tell customers, if you're going to buy hardware, buy the most expensive hardware you can find, because tomorrow it's obsolete. So buy the best you can get today, because in 6 months, it's no longer the best. VMS continues to improve. I do know that. I can measure that. Storage wise, yes, by all means, buy NVMe storage. It's the most expensive, but it's certainly the fastest. So where are you going to have to do some work? Probably your build procedures. If you cannot confidently build your application right now today on x86 and know for a fact that you're going to get what you're running in production, you may be in a tough spot. Maybe not. I don't know. I was just talking to a customer the other day that is pretty convinced that they don't have all their source code that matches what's in production, but they don't have a great way to prove it. That's the kind of confidence I don't want you to have. The newer compilers might do a better job telling you about bugs in your code. The /check and the /warning qualifiers, especially during development cycles, are going to be your friend. If you have bugs in your code, there's no promise that your bugs are going to remain silent.
See errors in the compilers, which
So the idea is, so the question is, do I see errors being reported by the compilers? So what I will tell you is, all of your development, especially if you're doing Pascal or COBOL or BASIC, maybe C as well, include /warn and /check on the compile commands. The newer C++ compilers from Clang does things much differently than the traditional VMS compilers in terms of what they like in the language and then how they tell you about it.
because basically you want to see the error at the compiler time and not at runtime.
Yes, I want the compiler to tell me as much as it can. I know people that run their code through some combination of Splint to tell them ahead of time what the computer thinks is going to be wrong with your code. It's a tough problem, admittedly, especially for large large complicated applications. All right, if your code calls change mode to kernel, change mode exec, change mode to supervisor, you also have made poor life decisions. That will come to probably bite you here. If you link sysexe, you're probably in good shape, not guaranteed. If you know about, we talked about the stack format and the AP and the FP and all that stuff, probably you're going to have some work to do. Anybody have command procedures that use TCO, despite my recommendation? Any scan users out here? If you've got macro code, whether it's macro 32, alpha macro or whatever, consider migrating to some higher level language, Bliss or C, just for sanity. If you're using ASM in your C code, don't. So here's some references to some brilliant presentations from the past.
Change the code to the translators to do that? Or do you just have to do it?
So the question is, are there any automatic tools to take alpha macro and turn it into C? No. Not that I found, or at least not that I've used. Yeah. And macro 32 already is a compiler, so we probably can argue about semantics. So to sum all this up, what we have today is 40 years of quality engineering that we've built on. And that this is able to work at all is kind of a miracle considering the origins of DMS. So we should be grateful for that. You're not going to be able to tell the difference sitting at the DCL prompt what kind of computer you're on. Everything you're familiar with is already there and it works the same. Floating point, probably, I tell customers, don't even think about it. And then if you come back to me at the end of the port and find a problem, then we'll think about it. Don't worry about data alignment. Test your application if you feel that it's necessary. I don't think it's worth the effort. If it compiles and links without error, just run it. And I do want to acknowledge dozens and dozens and dozens and dozens of people along the way since years and years and years and years and years that were responsible for making good decisions during the alpha port that helped make this one better. People that I worked with during this interim period when we were running early field tests and base levels that made it better. All right, give me some questions. We've got 8 seconds.
Yeah, so I read somewhere that do some is to wait source code to get tested. Technically,
So the question is, does DECnet over IP work on virtual machines?
Yes.
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 But look on your website, you see it doesn't work.
To trust.
No, I reading documentation.
I had an issue with that, and then they say, yeah, you can't, don't use it. There was something state that design, don't use DECnet on the virtual environment.
I would, okay, I don't know what it said. I don't know what support said. What I can tell you is I do it every day and I don't have problems.
Might be that in phase 4.
I do that.
Yeah.
Modifies the MAC.
So and that's, so if you're using DECnet phase 4, which changes the MAC address on the hardware, you have to, in your hypervisor, set a flag which says, allow it to change the MAC address and you'll suffer a performance penalty at that point, probably. But who cares? I mean, this is x86. It's infinitely fast. This way the sales. Come visit me afterwards and we'll log into my system and it'll probably fail during the demonstration. You don't run phase 4?
No, but
Just with work.
yeah, but if you do copies, yeah, it uses that Facebook.
Right.
It's just the underlying.
Yeah, okay, so,
Copy of.
okay, all right.
But in the end, it uses your DECnet MAC address,
Yes.
which is allocated to your LAN device. It's using that.
Okay, so, all right, I'm gonna digress for 1 second, because I think I know where this is coming from. So when you're running DECnet phase 5, you have the ability at runtime for DECnet to choose what transport it wants to use primarily to talk to a remote node.
Yes.
And it might be phase 4, it might be phase 5. Typically what I see is they say it's slow. And so what happens is we try phase 4 addressing first. After 20 seconds, it times out because nobody's responding on my phase 4 address on my LAN. Then it falls back and does DECnet over IP, so it runs the OSI transport and then it runs. It's a DECnet configuration problem on your system that causes that behavior.
It's a VM, it's a virtual machine.
Well,
It's a VMS bug, and I'm pretty sure it was a compiler bug in a certain example.
It's not easy to set up.
We will take care of it.
Yeah, we can fix that. What else? Questions, thoughts? Did I convince anybody to consider migrating or to avoid it? Did I swayed opinion at all?
Well, you didn't talk about C++ at all.
Please do.
I didn't also talk about SCI.
But still, there's no migration to migrate to executables and put it back into x86. Why not? Why not?
Write it.
Why
Go
not?
ahead and write it. And then you can sell it to everybody else.
There will be always some cases where perhaps you bought something, you have no source code.
Yeah.
Why don't you make
But you
something?
retire.
But I think it's, no, I'm saying this in earnest. Write it, and then you can sell it to everybody else. It's not an easy task.
Yeah, that I understand, it's not an easy task.
So why do you want me to do it? I will.
Keep in mind, they want to migrate to x86, that they have bought some applications, they don't have a source code, this something don't exist, they don't want to migrate them. Do you understand that?
Might not have a license to do that.
Yeah. What language is it written? You know, or you don't even have an idea. And does it run on alpha?
Yeah, also migrated, also. It was the Pascal in the backend, I've seen.
So an unscrupulous, clever person could decompile your alpha code back into alpha source code.
Yep.
Right? And then you have something that you could figure out what to do with. So don't deal with the executable at all. Deal with, decompile that back into.
But I have no option.
Hire me to rewrite the application. You describe, give me the manual for the application. I will rewrite it for you.
So the decompilation is working?
Well,
It's doable.
It's
I know
almost
people look at.
you know, analyze/image/section equal data, whatever code.
The SDA will give you the output.
SDA can do
You
it.
take that, you feed it through ChatGPT and you
Okay, then you can maybe try.
Yeah.
No, I understand that this is a strange question, but you have to be fine, as is the situation, so. You have some shared images, perhaps where you don't have any source.
But it's a nightmare to maintain that.
Oh, yeah, no, this is easy. I mean,
So what about the debugger? Is it now fully up and running? Can we debug everything? The debugger is fully up and running?
except where it doesn't work, yes. Yeah, it works. I mean, the debugger works. You're running 923, I assume.
Yeah.
Yeah, so
Update 1 has a better debugger.
Yeah.
Actually, my update 1 debugger is,
it's good.
it's now to the point where I think it's top.
Nothing is perfect, but it's really good. Just don't write bugs. You won't need to debug them. It's much easier.
Yes.
Oh, yes.
What do you want from my phone?
All right, that's all I've got for you today. Thank you.